Hey, what's going on guys, CHECKMATE here. In this video we're going to be implementing our checkmate and stalemate detection within our chess engine. So without further ado, let's actually start. So we need to define a couple of variables. The first one would be the legal moves counter, and I just want to create the variable called int legal moves. And the second variable to consider would be the in check state of our king. So let's say in check state of the king, or let's say is king in check, like this. So int in check would be equal to, so now I'm calling the is square attacked function, and in order to, so we need to provide two arguments. The first is the source square occupied by the king of the side to move, and the second argument is the opposite side to move that is kind of attacking the king of the current side to move. So let's start with the second argument. So this would be side bitwise ordered with a 1, and here I want to ask whether the side is equal to white, and if it is, then I want to get least significant first bit index for bitboards indexed by the white king. So this expression gets the source square where gets the square index occupied by the white king, and otherwise I want the source square occupied by the black king respectively. So just trying to grab this part and change the king to black king respectively, like this. Now let's try to compile and run this to make sure it's error free. So just open the terminal in the current working directory, and by typing make debug, and if it compiles, I want to run the BBC binary executable here. So okay, so it still runs, perfect. And now every time, so the next thing to consider, every time what legal moves equals to 0, it's important, otherwise we won't be able to increment this. So legal moves equals to 0, okay. And here we want to increment legal moves. So what does this mean? So if the move didn't fail, so if the move fails, we just continue to the next iteration of the loop from this part, from this line, and not going anywhere like in here. But if actually we get here, this means that the move was legal and it was made on the chessboard, and that's the reason to say legal moves plus plus, just to increment the number of the legal moves. That's kind of it. And now just right over in here, we need to check the following conditions. So I can say if legal moves is equal to 0, which means that we don't have any legal moves to make in the current position. So in this case, we might encounter two cases. So the first case, when king is in check, and the other case, well, king is not in check. So I can simply say if, and I'm referencing my in check variable initialized at the very beginning. So if it is in check, I actually want to return mating score, and I just want to return minus 49,000. So it's almost like minus infinity, but slightly less, to make sure that this value is still within the alphabet bounds, and plus ply. And this plus ply is incredibly important, guys, I can't overvalue the need of doing this plus play here, because otherwise your engine will be suffering from the issue of not finding the checkmate in big depth. So it would be finding the checkmate in depth of 2 or 3, but starting say from depth 4, it would fail to find a mate in 1 even, believe it or not. And I would better just demonstrate you this so you can understand and watch it visually how exactly this is happening, because that's one of the issues my early engines has been suffering from, and that's kind of really weird stuff. So else otherwise we want to return stalemate score, because stalemate score, because when we don't have any legal moves to make and our king is not in check in this case, that means that we are within the stalemate state of the game. So here we just want to return 0, which means a drawing score. So this is a draw. Well, okay, so yeah, probably I just get rid of this ply at the moment, just to demonstrate you what a weird disaster is going to be happening if we don't add this ply. So adding this ply allows us to take into account a mate distance. So by adding this ply, we are ensuring that our chess engine is considering the move leading to the closest mate possible head. So that's quite pretty important thing to consider. Well, okay. Anyway, I just want to go to my desktop and invoke the arena, and I just need to change the binary executable path for the chess engine. So engines, manage, and details. So I just want to change this from the previous part. So it's not search alpha beta anymore. It's now search stalemate, checkmate and stalemate detection. Okay, and this executable open. Okay. It would probably be playing somewhat similar game. Well, actually, yeah, it's already playing probably a little bit different, but it's not the case really. So I don't really want to watch this. I just want to show you another little thing here. So let's go to set a position, and if I just clear the chessboard and let's put a poor black king on the 8th rank, then let's put a white king, well, say somewhere here, and the black queen, well, let's say somewhere over in here. Okay, and this would be white to move. Okay, and also just want to make sure that the depth, well, let's start from depth 2. So at depth 1 it shouldn't really find a checkmate because it doesn't take care about the opponent's moves. So only starting with the depth of 2, it should be capable of finding the checkmate, if any. So it should now mate the opponent. Let's check this. Okay, something has gone horribly wrong, or what happened? Just have no idea. So okay, just want to copy this position and trying to store it somewhere. Okay, let's compile the source. Okay, it's probably, so if it doesn't make a move, I'm not sure why it doesn't make a move, to be honest. It should have. Wow, this gives an illegal move for some reason. This is a little bit strange. Okay, so well, anyway, A8 move means that the best move is actually is not has not been initialized. So I just want to try a little hack here. So if best move like this, oh, this is happening from time to time. This won't be happening when we implement our our collecting of principal variation, obviously. Yeah, but for now it's a bit unfortunate. So these placeholders I'm using are not always that stable. And okay, let's try to find a move. Okay, now hopefully, yeah, now it finds the mate. So yeah, just this will change so only best move is available. In this case, just print in this print the best move. Okay, so what I wanted to say here is that at the depth of 2, it finds the mate. Let's adjust the depth to the depth of 3 and try to find the best move again, and it still finds the mate. But if we now go to depth of 4, it now shouldn't find the mate anymore. Let's have a look. Well, okay, here it still finds the mate. Okay, but at the depth of 5, it really shouldn't be. All right. Whoa, this is a bit strange. Okay. Well, probably maybe the nature of position is that we always find this move. Okay, just let's make depth of 6. Check. Okay, so this is what I wanted to show you guys. You see, like up to depth 5, it was actually finding the best move, but at the depth of 6, you see, it's not capable of finding the proper mate in 1, believe it or not. So we have the 6 half move depths, 6 half moves depth here, and we didn't find the maiden move. So this is really weird, right? So if you're gonna encountering this in the real game, this is really unfortunate. Well, hopefully my early engines could hardly reach the depth of 5, so this wasn't really that big issue for them. But anyway, so in order to avoid this sort of a weird behavior, we need to do the following thing here. So we need to add this plus ply, and this fixes the issue of not seeing the closest distance to the maiden position. So let me just compile around the code again, and from now on this already should have be capable of finding the mate in 1 in the depth of 6 as well. So let's try again. So we're at the depth of 6 now, right, and now it finds the mate. Perfect. So let's increase the depth even more. So let's make it the depth of 7 and try to find the mate, and it finds it again, and so on and so on. So this is the exact fix that I wanted to emphasize, basically, because again, like it took me really lots of efforts to like it's even hard to ask the right question on Talk Chess forum, like why in particular your program doesn't see a checkmate. So if you just post the code there, that it's hard to believe that somebody would actually notice the lack of this plus ply. But fortunately, some of the guys actually saw this and kindly pointed out to me that I just missed this ply, and that was the issue why my engine didn't really see the mate. So this plus ply is incredibly important to find the closest mating position. Let's even emphasize this here. Return mating score, and here assuming closest distance to mate, distance to mating position, like this. Assuming closest distance to mate in position. Yeah, this is it. And one more little thing just from the previous part, I did a grammar mistake. I spelled recursion with 2 R's. Sorry for that, guys, so already fixed this. But obviously it's not the point regarding the chess, how the chess engine is kind of playing chess. Well, okay guys, so this is it from my side, and before we end this video, let me just introduce another issue we're supposed to be fixing within the next part. So if we just set up the level to only 1/2 move, then it would start suffering from so-called horizon effect, or in simple words, just giving pieces away. So let's analyze what has just happened here. So in this position, in this particular position, black thinks that after taking this pawn, he would be a pawn up, hence better. And without calculating any further on, he just grabs this and he thinks that he is now actually kind of better. We didn't yet implement showing the scores, by the way. It's a good idea to do so. So here I can also print the score. So and in order to do this, we need to use the USA command info score CP, and then we go for a decimal specifier, and then we want to print the depth and the decimal specifier, and we also want to print the notes and long decimal specifier here. Also, we would be printing the principal variation later on, but now it's not really the case, and the new line obviously. So I just want to print the score and depth and the notes. Okay, so let's try to compile and run the code and try to reload my arena. Okay, and start it again. So it now should be printing the scores. Let's see if this is gonna happen. Okay, so now it prints the depth and the score, which is great. So let's make a couple of moves, and again, so here it seems like so black is thinking that he is a better well, let's just make the next move. So you see, like after capturing this pawn, black actually thinks that he is a pawn up, and even this 80 says that he has a better position because of kind of better pawn this positional pawn score, or maybe some other reasons. Doesn't matter. I just want to emphasize your attention at the point at the matter of black actually considers this position to be better, so he considers to be pawn up, but he can see that his queen is going to be recaptured in return. So if we just make a next move, now we see like white already is better, is queen up basically, but black didn't really see that. And if we just try to make some moves, it would be again the same disaster again. So he just he goes this move, okay, and black can see that its queen is gonna get captured, and he just captures a pawn, and he thinks he's not a queen up but even a pawn up after this move, and he can see that the next move actually loses its queen. So this insane stuff that is happening to the scores is known as the horizon effect. So the idea behind this term is the following. So the search has no idea like what's gonna happen behind the horizon of the fixed depth. So in order to avoid this sort of behavior, we need to implement something known as the quiescent search, and that would be the topic of the next of the next video. And the idea behind the quiescent search is actually to search only forcing lines, so involving only those moves that are captures. So it would be searching captures until reaching the so-called quiet position, which means that there won't be any more captures within the position, and only then he would be bringing back the static evaluation. So that's the idea behind the question search, and that was the little teaser regarding the next part within this Bitboard chess engine AC series. Well, okay guys, so this is it from my side. I hope you enjoyed this tutorial and learned something interesting out of it. So I hope to see you in the next part. Until then, and take care.